All right, so again, when you expand multiplication, you add any exponents, you put out front of your log. Division, we do what? Subtraction. So here we have a division problem. So we're going to change it to subtraction when we expand it. So this is log base 3 of 1 minus log base 3 of 27x. Is it finished? No, because there's still multiplication there. Where's the multiplication?
Oh, the x, yeah.
27 times the
Sorry,
x,
destruction.
right? So it's log base 3 of 1 minus log base 3 of 27 plus log base 3 of x. Now, since there's this addition in here and we're subtracting both of those, what's this negative do to both of those? Makes them what? I heard somebody say it, I thought. Yeah, distribute that negative 1, what happens to those two logs? They turn to negatives, right? Also, we should know this answer. What's this answer? When that's a 1, what's the answer always?
I don't think it's 1.
Sophia? 0. So that's a 0. So when you get log base of anything and there's a 1 after it, the answer is 0. So you guys should recognize that. Then it's minus log base 3 of 27 minus log base 3 of x because we're distributing the negative. So you don't have to put the 0. If you do, it's okay. But if you just had negative log base 3 of 27 minus log base 3 of x, you have expanded it correctly. All right, 3 and 4, we're going the other way. Addition of two logs will turn into multiplication. Subtraction of two logs will turn into division, right? Any logs, any numbers out front of logs, what do we do with those? Make them exponents, right? Okay? So, the first thing, I'll just do one step at a time. Some of you can do more than one step at a time, and that's okay. This will be natural log of x cubed. Can't do anything to that, and can't do anything to this. There's no exponents that I can do. So the addition we turn into what? Multiplication. So normally when we have a number and a variable, we put the number in front of the variable, right? And the subtraction we turn into division. So there's our condensed log.
Sorry, Taylor.
Yeah. Did you go back up?
So the second one?
Yeah. Yeah, like right there.
I'm good.
Hi.
Yeah.
All right. Question on number 3? Natural log of 9x cubed over 2y. Whoa.
What the? Whoa.
Whoa. Okay. Number 4, we've got two numbers in front, so those two numbers become what? They become exponents, right? So the original problem is 4 times the natural log of x plus 8 times the natural log of y, which means that's the same as the natural log of x to the 4th plus a natural log of y to the 8th. Since it's addition, we can turn that into a single log that is multiplied together, those two. Simple, right? So you'll have 2 expanding problems, 2 condensing problems. Okay, 5 and 6 is supposed to be your favorite rule, and you guys are forgetting it, which I don't understand why you would forget your favorite rule of logs. When we first started logs and trying to do these, you back with us? All right. When we first started doing these, we had to try to do this in our head, we had to write equals x and then try to figure it out, right? Well, now we don't have to do that. We can just put in our calculator log of 8 divided by log of 4. And that was 1.5 or 3/2 if you have the fraction. Right? Just put in your calculator. That's all you gotta do for 5 and 6. So number 6, I have log base 3 of 127. So in the calculator, I'll put log of 127 over log of 3. And that's -3. When you put that in your calculator. Anybody having issues putting that in your calculator? Just make sure you close off your logs when you do that. Okay, because when you hit log, it always gives you that left parenthesis. Make sure you close it off. Okay? Should not miss 5 or 6. Number 7, we're solving an equation. I have a log on each side. So these are really easy. Why?
Can you just get rid of it?
You just get rid of the what?
The log.
Yeah, the log. If the log base 7 of 4x minus 1 equals the log base 7 of 23, that means 4x minus 1 has to equal 23.
Yeah. True.
So add 1 and divide by 4, and you get 6, right?
That's okay, you were close, man. Maybe next time.
Number 8, we have a single log on the left. So what do we do to these to solve them? Turn them into what? Exponential problem, right? So the number after the log, the x minus 6, is equal to, what's the base? And what's the exponent? 5. What is 2 to the 5th?
32.
32. What's 32 plus 6?
38.
38. Simple.
We're home. We're home.
Okay?
Give me your paper.
So that stuff we learned right when we started these logs. How to write it in exponential form. That's all we do with a single log on the left, and that's what you need. A single log on the left equal to something, just turn it into an exponential, whatever the base of your log is.
Bless you.
All right, 9 and 10 are exponential problems, equations. And how do I get these exponents to the main level, ground level? How do I put them out front? What do I have to do to both sides? Turn them into what? Logs, right? Vince, pay attention.
That was me. That was all me. That was all me.
All right, so when we take the log of both sides, that means from our logarithmic rules, or rules of logarithms, we can put the exponent in front of the log. Now we have our exponents on the same level.
Taylor, that's one right. That's one right.
Okay? So what do I do to both sides now?
Yeah.
Divide one of the logs over, right? I like to go left over. So I like to say log of 8 and move it to the right. But if you wanted to move the log of 2 over to the left, that would be okay. You would do the same thing, you'd still divide. On the left, the log base 8, or the log of 8's cancel, so I get 2x minus 1. And on the right, log of 2 divided by log of 8 is 1/3.
That's good, AJ. That's good. You make a joke.
Sydney says 1/3. You guys agree with her?
I don't want to. Negative 1/2.
I think you're right, Sydney.
Oh, I get some add-
Why won't it
I
hide?
had no idea.
I've got a camera in here. What?
There we go. So log of 2, close it, divide by log of 8, close it. Yep, 1/3. Okay. If you're not sure, hit math and enter twice, right? Yeah, I don't know how that 8 got there either.
Okay, just making sure.
Should be a 4, right?
Yeah, I see what you did though.
I was looking at log of 8 or something.
Because there's a bunch of 2s.
When I do that 1/3 now,
Yeah.
distribute, right? So I get 2x minus 1 equals 4/3 x minus 4/3. All right, so I'm going to subtract the 4/3 x. I'm going to add the 1. I'm doing 2 things at once here. So the 1's cancel and the 4/3 x cancel. Now, how many thirds is 2? What's 2 times 3? 6. So 6/3 minus 4/3 x is 2/3 x, right? How many thirds is 1? 3/3. So what's negative 4/3 plus 3/3? Negative 1/3. How do I get that 2/3 to the other side? Divide by 2/3. What's easier though? Multiply by 3 seconds, right? The reciprocal. What happens to that top 3 and that bottom 2? Cancel. So that's negative 1/2. The 2's and the 3's cancel, so that's that.
You saw what I did wrong. It was simple.
Simple. Of course, so simple.
Told you.
Okay? And number 10, same thing. We're going to take the log of both sides. So I'm going to write the log right away of 7 to the 9x power equals the log of 15. And then I can say 9x times the log of 7 equals log of 15. Our rules for logs says I can move that 9x out front. Divide by log of 7, both sides. And log of 15 divided by log of 7 is 1.39. And then all I got to do is divide by 9 to finish up. And x is 0.155. I kind of rounded it. Another simple one, right?
Yeah.
You got them all right, didn't you guys?
Yeah.
Awesome.
I got one.